Hello. Morning, everyone.
Happy Friday, people.
Yeah, happy Friday. Yeah. Uh, good. So let's start. Okay, so today's Friday. Uh, so let's finish this week's lecture. Let me share my screen. Okay. So hold on 1 second. Let me try to connect my second screen. Hold on 1 second. Okay. Then let me share the screen. Okay, looks good. Okay, so I think last lecture we were talking about application level protocols, right? And we also talk about what kind of the transport level service does an application need, right? So still remember, we are talking about the data integrity, the timing, if the time is sensitive or not, throughput, and the security, right? And we are using some examples to illustrate different demands from the different application, right? So for example, if we want to transfer, download the data integrity is we cannot tolerate any data loss, right? But the throughput is elastic, right? So it can be high, can be low. We can tolerate high speed or low speed. That's fine. But as high as possible is good, right? But we can tolerate if sometimes the throughput is low. It's not quite sensitive. And for email, we cannot tolerate data loss, right? So on and so forth. But differently, if we are watching the audio or video, we can tolerate some data loss, right? And but we require a high throughput for the real-time audio or video teleconference, something like this. We cannot tolerate so high latency, right, or delay, right? So the time would be sensitive to these applications. Similarly to the streaming audio, video, and interactive gaming and text messaging, right? Different applications have different demands and different requirements, okay? Because the different demands and the requirements, we should use different kind of the transport protocols, right? Still remember, we generally or we roughly talk about TCP and UDP, right? So the TCP is uh, it's a reliable transport protocol, right? But the UDP is unreliable data transfer protocols. So for TCP, it has some good features. It has a reliable transport, as we previously watched the video, right? So if you lose some packet, and if the receiver cannot acknowledge it to receive the packets, then the sender will need to resend that again, right? And it has a flow control. The sender won't overwhelm the receiver. So the sender doesn't want to overwhelm the receiver to make the receiver has a high queue of the packets, right? And high number of the packets in the queue, right? And it can has a congestion control. It limits sender when network is overloaded, and but it cannot provide the timing guarantee, right? Minimum throughput guarantee, or cannot provide the um, security things, right? So this is a things they cannot, the TCP cannot guarantee, okay? But for the UDP, from the name, you can tell that it's unreliable data transfer, right? But the problem is that it cannot provide the reliable flow control, congestion control, timing, throughput, guarantee, security. It cannot provide a lot of things you can see here, right? And it can not guarantee the reliable data transfer. Then my quick question here is why we need a UDP, right? I think I mentioned that in the last lecture, but quick question, why we need a UDP? If you know that, you can say or type in the chat. So UDP cannot guarantee a lot of things, but why we need the UDP?
Sometimes it's not important to have data integrity. Like if you're for streaming video or streaming audio, it's more important to just continue the stream than it is to make sure that every piece of data is delivered.
Yes, that's right. Yes. So if you are using a one word is a speed, right? Speed or throughput is a or low delay, right? So that's a key feature of the UDP. Yes, thanks. Yes, yeah, that's a good answer. Um, Yes, so UDP is still has a lot of cannot guarantee a lot of things, but it can provide as high speed as possible, right? So sometimes we prefer to use UDP in some applications. I think I have already showed this table in last lecture, but let's look at this table again, right? So for the application like streaming audio, video, or real-time audio, video, you can use UDP, right? The data could be lost, but that's fine, right? And for other cases, still TCP would be a best choice. We will show you a demo. We use a remote terminal access telnet to communicate with a web server. In that case, if you lost some packets, that would not be good, right? You cannot access to some web server. So for the secure things, we have the securing TCP. We have some protocols named Transport Layer Security, TLS. I think previously we have some, it's a previous version. We call it SSL. Maybe some of you uh, know that. Um, so SSL is a secure sockets layer, right? But this newer version is Transport Layer Security, TLS. Maybe you notice some secure protocol here or there, right? So for the TLS, it can provide the encrypted TCP connections because the vanilla TCP or UDP sockets just send the packets without any encryption. Okay, so it's just a plain text or clear text password, right? So everyone can read or can understand that, right? There's no encryption there. So that's not good for the computer security or internet security, right? Network security. Sometimes people want to have a encryption uh, for their packets, right? So the other people cannot just get their packet and understand the content, right? So the TLS can provide the encrypted TCP connection and also provide the data integrity endpoint um, authentication, right? So the TSL implemented at application layer, right? Application can use a TSL library which talk to TCP. So you can think about that. It's a application layer library, right? You can use a TSL library when you want to talk to TCP, right? You just add another layer, right? Just like when you send the data, you just add some encryption there, right? After that, you send the data packet to the TCP. You just add another layer. So if you don't want to guarantee the security, you're fine. You don't use that library, right? So you understand some library, right? So when during the application, you can call some library to help you do some computation, do something. After that, you just return back to the main application, right? So we will talk about more details about the TSL socket API application interface there, programming interface there, okay? But here is just a quick idea if you want to make sure some security thing, because as we mentioned, the TCP and UDP cannot guarantee security. So people want to have another level, or you can think about as a middleware or a library, right? So to provide this capability. Okay, so
About when did they start introducing this heightened level of encryption in things like email?
so you can see here, so we will introduce the web and the email, but for the encryption, the email, we may not introduce here. We will put all the security things in the chapter 8, the later chapter. But starting from now, we are talking about different applications from web, HTTP to email. That's the thing I'm going to talk about. Okay.
Okay.
Okay, thanks. Okay, let's talk about the web and HTTP. So I think this is the most important, I can say this is the one of the most important applications you are using every day in the internet, maybe more frequently than email, right? Email, you just receive several minutes or several hours, but web, you almost using every time when you serve, right? So what is a web, or what is HTTP, right? The most important thing is what is the HTTP protocol, right? We want to talk about here. So let's first quickly review what is a web page, right? Everyone may know that the web page consists of a lot of objects, right? Each of which can be stored on different web servers. As we mentioned before, we have the web server and web client, right? Client talk to server, server provide something back to the client, right? So this is just the client and the server paradigm we described. So yeah, this is very classic. And the object can be HTML file, JPEG, image, Java, and the audio file, right? So, but generally speaking, for plain web, if you want to establish a website, just several lines of HTML file and JPEG image, you can do that, right? It's not necessary to be very complicated, right? And web page consists of based on HTML file, which includes several reference objects, each addressable by a URL, right? So the URL is quite straightforward. You have a host name as the beginning, and you have some path name right after the host name. Okay, so this is the general URL, and you can see almost everywhere when you input the URL into your browser, right? And then what is HTTP, right? The HTTP is the most important concept we want to introduce here. So the HTTP is first it's application level protocol, right? And specifically it's a hypertext transfer protocol. Okay, so it's HTTP, right? And it's used by the web application, okay? And it's a application layer protocol, as I mentioned. So it follows the client and server model, right? I just mentioned that. So for the client, the browser, right? So everyone has a different browser, Chrome, IE, or Firefox, different browser, right? That request receives, that can request, send the request, right? Receive, just receive the response, right? And display the web objects from the HTTP using the HTTP protocol. Okay, that's the basic concept. And the server is that the web server sends objects in response to the request using the HTTP protocols. You can think about client using the HTTP protocol, right? Send the request to the web server, and after they after they get the web object, they just display, right? Just display the HTML, the image, or whatever objects in their browser, right? The server is just they receive the request and provide the response and send the content, send the objects back to the browser, right? The client. So that's a quick demo here, right? So the PC running Firefox browser send a request, HTTP request to the server running Apache web server, right? You have to install different web server. Okay, if you quickly Google search web server software, you can identify a lot of web server software. Different web server software provide different capability. Let's say here is open source Apache web server. Okay, you can install this server in any um, local or I mean server or workstation. Okay, and the HTTP request sent to the server, and the server responds the HTTP responds the HTTP send the HTTP response back to the PC. Okay, running on the browser, and the browser will display the content sent back by the server. Okay, similarly to the iPhone, right? Your iPhone, you running the Safari browser similarly. So also you can notice that, right? The iPhone cannot talk to PC, PC cannot talk to iPhone. That's the basic server and the client model, right? Both of them are talking to the web server here. So also the HTTP uses the TCP transport protocol, right? So HTTP is the application protocol. TCP is the transport protocol, right? I emphasize this again and again because I want you to remember that in the future, people are talking about HTTP and the TCP. They are in the different layers, right? This is a very basic concept you need to remember, right? They are not in the same layer, so that the HTTP can use the TCP to establish the connection. Okay, so the client initiates the TCP connection, creates a socket to the server port 80. I still remember, if you want to establish the socket, or you want to talk to the different processes running in the host, right? You have to give the IP and the port number, so that you have to provide the URL here, right? URL is just the, you can, know the IP address, right? And then you will have to specify the port number 80 here, right? Because 80 is for the TCP, HTTP process running the host, okay? And then the server accepts the TCP connection from client, and the HTTP message exchanged between the browser, the client, and the web server, okay? And finally, the TCP connection closed. So this is, you can think about this like several steps. First, using the HTTP client, using the STCP to establish the connection, and server accepts the request, establish the connection, okay? And then HTTP messages exchanged between browser and web server, finally connection done. Okay, and one of the thing you may want to know that is HTTP is a stateless. It doesn't record any previous information, previously or past client request. It just do what they need to do now. They don't record anything happened in the past. And we will talk about, there is some like thing like a cookies or something will record the past history. But for the HTTP itself, the protocol itself, it doesn't require any previous information or past history. Okay, because record thing will spend time and will have a lot of overhead, right? So for the protocol itself, it's doesn't remain or maintain any state. Okay, so this is some reason here, but generally speaking, it's complex and sometimes time consuming. So HTTP itself doesn't record any state or privacy information. Okay, and we have two different types of connections. One connection is a persistent HTTP. Another is a persistent HTTP. So different version of the HTTP will provide the different kind of the capabilities here. Okay, and so here is a quick explanation why we need to have the two different type of the HTTP versions. So simple sentence to explain the difference between them is that non-persistent HTTP at most send and receive one object over one TCP connection, but persistent HTTP can send and receive multiple objects. Okay, so like I talk to someone, I establish the connection with someone, and we can at the most send or receive one thing during one connection. But the persistent, if you establish a connection, you can send and receive multiples, right? So that's why you can think about nowadays, we are almost using the persistent HTTP 1.1. Okay, I will show you a demo. I will input in my terminal, okay? And to let you know how we establish a connection and send and receive. But generally speaking, you remember nowadays people are using the 1.1 HTTP. In the future, 2.0, 3.0, different upgraded HTTP version. But from this slide, you can simply tell that, right? So establish one connection, send and receive multiple objects, that would be nice, right? But we can do some analysis why it's better, right? So you can also do that. You just think about you save a lot of time here, but we can do some analysis here. Okay, let's see first a non-persistent HTTP example. Okay, you enter user enter a URL here, right? Some school, some web page. You can input www.wsu.edu or slash some website, right? Or School of ECS, something, right? And then we HTTP client initiate TCP, and the HTTP server we establish in the university, right? University has the HTTP server, and we'll accept this connection. Okay, notifying client. Okay, I accept your connection. Okay, we have already established the connection. So this is the first round. Okay, then the second round is okay. HTTP client knows that you accept my uh, request. We have already established the connection, and then I just send the message to indicate what kind of the object I want to get. Then I will go to the specific department homepage and some image, some document I want to get, right? And then HTTP server receives that request and responds the message containing the requested object and send the message back to the socket to its socket and through the link and the thing we provide we previously talked about, right, back to the HTTP client, and the HTTP client gets the message and display the contents, and the HTTP server just closes the TCP connections. Okay, that's you can see here we at least have the two round of the send and receive, right? First send and receive establish connection. Second send and receive send the objects and receive the objects, right? So each time we can only repeat it for, we can only tackle or I mean take care of the 10 JPEG objects. If you want to do more, maybe you need to do another round of the connection, establish connection and send and receive. Okay, so here, this figure I think is a good figure to quickly demonstrate you how these two rounds happen, right? This figure is straightforward. Send initiate TCP connection, okay, back, and then request file and back, right? So if we are talking about one concept, we define one time. It's a time for small packet to travel from client to server. And then we can calculate or estimate what is the general time if you want to get the content from the TCP, from the HTTP server, right? So here we define time is for small packet travel from client to server and back. So that's what I use round, right? You can use another word, but this is what I mean for round, right? One send and one receive. This time is RTT time, right? Uh, Short for RTT. It's packet send the travel from client to server and back, right? This is RTT. So generally speaking, the HTTP response time per object is we need to do, as I mentioned, we need to do 2 rounds of RTT time, right? So it's a 2 RTT plus the file transmission time. So the last time is easy to understand because if you transfer a large data, large image, right, then the transmission time would be large, right? But the RTT time sometimes is kind of stable if the HTTP server and the client connection is stable, right?
I have a
So,
question.
okay, go ahead.
Yeah, so how do you define this a small packet? Like, what does that mean?
Okay, the small packet is because you send the request to the HTTP. You have to send some request, and then the HTTP server will send back the response to you. And how we define the request and the response, that's a very good question. So I will show the slides later because generally speaking, we have the request message and the response message. Okay, so if you think about here, that's we send the HTTP request message, that file, to the server and receive the response HTTP message file from the server. That's a packet. Okay, and after that, you still need to send the data along with the message, HTTP request or response message, right? So that data is the file transmission time.
Got it.
I answer your question?
Yeah, I think so.
Okay, okay. So no, if you still, don't quite understand what is transferred between the server and the client, that's totally fine. Because we will give you, as I show, I will give you a slide. The slides will tell you about what is HTTP send message and request message and how the data will attach with the message itself. Okay, but now you just think about that HTTP server and client sent some packet or message, something, right? Something, we will talk about that thing later, but we will send something and one round is RTT time, but for the non-persistent HTTP, you have to send 2 rounds, right? Or you have to do 2 rounds, send and receive, right? And along with the file transmission time. So you can think here, if we want to do a one object, right? Or maybe previously we mentioned the capacity for here is 10 objects, right? So for one connection. So if we want to do these things, we have to establish a connection for one time, right? But if we want to do another time, we have to establish one other time. So this is not very efficient. That's why people invented another is a persistent HTTP, HTTP 1.1. Okay, so the server just leaves the connection open. So let me check the chat if there is any question. Okay, so I think that's that's some reference. Okay, so the server just leaves the connection open, right? And the subsequent HTTP messages sent and received between the same server and client, time to time, over the open connection, until the client send a request to close the connection. Then everything is done. So this scheme will guarantee you to have one RTT for all referenced objects, right? For example, I have 100 images I want to load in the website, right? You don't have to do 10 times of connections. You just do one-time connection, spending one RTT time, and then the other time just a file transfer time, right? So that's the quick explanation why people are trying to use a persistent HTTP. And nowadays, I think almost the HTTP protocol are based on the 1.1. Okay, um, that's an idea. Okay. Um, is there any question here? So then we will talk about what is send and receive between the HTTP request and the response. But now this is just a quick explanation how server and client establish the connection and send and receive the response and the request and receive the data. Okay, that's let's say this is a workflow. Okay, this is a workflow. Okay, high level scheme workflow. Okay, so if there is no question, let's continue. Okay, the later this slide will give you the very detailed idea what it has been sent and received between client and the server. Let's spend some time looking at these two slides. This slide is the first slide just to give you the overall example of a request message. And next slide will give you the formal definition of the format, okay? But let's see, so here is a HTTP request message. The client will send this request message to server side, okay? This is the first message it initiates. So let's see what has been contained in this message. So you can see the first line is a request line. You have to tell what kind of the operation you want to do or what kind of the HTTP method you want to do. So here we have the different command. We have the get, we have the post, we have delete, we have other commands. I will talk about that later. But simply speaking, get is the simplest command you are using, right? You just get to the website. You just want to you want to see, right? Check the website. You don't want to update. You want to delay. You don't want to do anything else. You just want to get, right? Get is the simplest command here, and then after get, you will add a URL here. So this URL is just as we see, it's the index.html. And later, next is the HTTP version, right? As we mentioned, HTTP/1.1, and it's a return character and the line feed character, right? This is first line is a request line. Let's say if the format, the first line will be the request line, okay? This is a method, as I mentioned, get space URL index.html, right? And space version HTTP/1.1 space, okay? And the return if this line is ended, right? So this is the first line, request line. And then we will have the header lines. So in this example, we will have the different header lines. For example, we'll have host information, we have the user agent information, we have the accept language encoding, characters and whatever. So, but I will do a simple demonstration here. These are not necessary, okay? So a simple example is that we just need a request line and we just need a host line. Then we can send this request, okay? It's not necessary to include the other, I mean, this information are extra, right? You have to tell the HTTP server what kind of the encoding you want to use, or what kind of the language you want to use, but this is not necessary, right? So if we want to do a quick demonstration, I will ignore this part. Okay, I just, sorry, I should use a laser point. So I will ignore this part, okay? I will just add the request line and the host line for the header lines, that's fine. And then I just send this request to the host, to the server, and then the server will respond to me. I will give you a demonstration in about 5 minutes, but let's just finish this format thing. Okay, so let's summarize HTTP request message general format. Is the first is the request line, as I mentioned, different method, right? Delete, get, patch, or some other method, right? And the URL here, and the HTTP version here, and the return, right? And then after that, it will give the domain host name, right? And the other values. Later is the other information, just I mentioned, language, encoding, compression, something here, right? And after that is a body, right? So if we look at this, this is a real HTTP request, right? It's exactly follows our format here, right? We have the host URL here. This is the path here, right? Version here. And then it's the header, sorry, headlines here. And this is the contents. Okay, so this is the HTTP request, simple request here. So I think I should do a demonstration before I go into the next content. Okay, so let me first follow this step to get the HTTP request, okay? And then I will talk about some response, right? This is the first request, but let me first do a demonstration that will help you to understand this whole procedure. So I have a terminal sharing here, okay? I think you should be able to see here, right? And everyone can see here, right? And I can use telnet. Maybe I should just also share the slides as well. Just share the, maybe I just share the whole screen, okay? So this is my terminal, right? I have already installed this software, okay? Telnet. If you don't have this software, just download in brew install or apt-get if you are using the Linux or MacBook, right? So you have a terminal with the Telnet installed here. So Telnet just with, as we mentioned, it's a application level protocol, right? So we can do the Telnet. Similarly, we can do the, this is a University of Massachusetts server, right? And first, we open the HTTP connection to the port 80, right? And you can see here trying to access to the IP here and the port here connected to this HTTP server. That means we have already established the connection, right? And after that, I need to get something, right? So let's just copy this. Let's just copy this whole thing here. Okay, so I just get and host, put the host name. I do not need to put the, I do not need to put the language or some other things here, okay? You can see I just add the get, the URL, and the HTTP version. And for the headline, I just add the host path or address. Then I just put enter, right? So after this baseline, okay, the HTTP server respond to me, okay? So we will talk about the responses message of the HTTP protocol, but I want to quickly demonstrate that if you are using the telnet, you can first establish the connection with the host HTTP server. After that, you just use the get API to get the contents from this web page, right? And then you will get the HTML, all the things right here, and your browser will just display this HTML contents in your browser, right? So any question for this demo? I think this demo is very straightforward. I may do that again, but before I don't think today we will have time to describe the HTTP response. But I want to let you know that using the telnet, you can quickly establish the connection with the HTTP server, and you can also use the API GET to get the contents from that HTTP server and return some HTML files to you, back to you. Okay, is there any question about this demonstration? I think this demonstration is straightforward. We just put the first request line, the second headline with the host name and the value, and we enter a space line to send our request. So no question. I think I should share this, right? If no question, let's continue. We just demonstrated one HTTP request method, right? But as I mentioned, GET is not the only thing you want to do with the HTTP server, right? Sometimes you want to establish a web page. Sometimes you want to delete a web page if you have the permission, right? I assume if you have the permission, you can use the request message to do something more than just a GET. But mostly we are doing the GET. We just browse the internet, right? But sometimes we can establish, we can delete, we can patch, we can do a lot of actions, right? Let's say actions, right? Or I mean, operations, right, to the HTTP server. So generally speaking, we have the post, we have the get, we have the put. There are some detailed explanations here, but I want to quickly summarize these things here. You don't need to remember all the details very specifically. So you just remember get is to get the data from HTTP server. Put is to update the data at a source resource, right? Post is to create the data other resources. Delete is just to delete. Patch is to partially update the data. So some of you may ask, what's the difference between put and the post? So here, put is to update. Post is to create. So if you want to establish a new HTML, right? Maybe in the HTTP server, you first need to post, right? Create a new HTML file there, and then put is to update the HTML there, right? And after that, you can do the delete, right? But if you want to do the partial update, you can do the patch. Okay, but I think in our demonstration, we just simply demonstrate the put because we don't have the permission to create or get, right? If the server is maintained by myself, I'm the maintainer, I may create, I may post, I may put, I may delete, right? But if you just access other people's web page, maybe you can just get, right? You cannot do anything else to modify other people's web page, right? So this is some HTTP request messages. And yes, I think that's the thing I want to talk today. But next week, we will talk about HTTP response message. You can first check these slides, but different from the request message, the server will respond to you, right? So if your request is okay or not okay, right? And what kind of the thing I need to let you know, right? And finally, I need to attach the data you want to get, right? Just as I did in the demonstration, I send the request. You can see the response, the HTTP response me something. Maybe you didn't pay attention here, but let's say the HTTP server respond me message is that, okay, you are okay, and the date, and finally it returns me the HTML file, right? So you can also do this demonstration in your laptop. It's a very simple demonstration, but it will give you some idea what kind of the thing or message HTTP request will include, and what kind of the information will be included in the response message here. Okay, so yeah, maybe I just finish these two slides. This is the response message, and this is the example of the response message. Okay. So we first will tell you if it's okay, and the date, and the server name, and some other information, and finally we'll return you the web page content that will be displayed in your browser. Okay, so that's it for today. I think today we almost finished the HTTP protocol, the basic information, and what kind of the thing will happen between the send and the receiver, between the host and the client. Okay, so any question here? Let me see, there is a question in the chat. For question 7, hold more is the equation when you're using D-transfer deproportion or 3 links and combining it for today to total delay. I think for question 7, the TA has already sent a clarification, right? So Marco, I think TA has sent a clarification. So for the queue time or for processing time is tiny. For the queue time, I think he claims that it's 0, right? And the time you need to use, I think it's transmission time and propagation time there. So if you check your email, you will find the clarification email, I think. Yeah. Okay, so any other question? If no question, let's done today. And I hope everyone enjoy your weekend. And don't forget next Monday, I think it's due date, okay? Please make sure you submit your homework before the deadline. I don't want someone send me email for some extent. That's a very simple assignment. And after that, here we'll grade your assignment and post the score. Okay. So if no question, yeah, that's it for today. Thank you, everyone. Yeah, have a good weekend.